I wonder why the video quality is not very clear. The video quality.
It's like, just like it's okay. Tr.Sheena chose. We just did this one. Just to focus on.
Okay, so some of you had covered water from school. Had any of you finished the topic? Or some of you had, okay, may soon they hadn't finished the topic. Okay. What about the rest?
About it.
You had learned about, had you finished the whole topic of water?
I said we have never learned about it in Central.
Oh.
We had never.
Okay, so in Central people haven't learned, even in what? Even in East? In East even people had South. Not yet started, even in South. Yeah, all those are the streams we have. That means none of you had covered water. So what were you, we have never learned about it in South. Okay. So what were you looking at before they sent you home?
Air. In Central, we're looking at air.
Okay, so had you finished air?
No, we are just.
Okay, so if you had not yet finished air, then I think we should discuss air first. Then after discussing air, we can come to water. Though for the people that were with me, I didn't come to class for East. Who is the teacher for East? Anyway, it was a short time. It was only 1 week, so I think maybe the person was still called up somewhere. Remember, you people were only here for 1 week. So, okay, so since some of you had not yet finished air and some of you are just starting, I think we should first discuss air and then we shall go back to water. Okay, so Mason says they were still looking at purity of substances. Okay, so you people hadn't even reached air in South. Okay, so I suggest that we start from air, we discuss about it. Then when people are comfortable with air, we shall go to water. Yeah, I thought people had finished the things before water. Okay, so let's look at air instead. Yes, please. Okay, so what have you looked at under air?
We had done what makes up air, the arrangement of air and properties of air, and the difference in altitude in air density.
Oh, so basically you had looked at air and its properties. Okay, so what do you remember? What is air? What do you remember? What do you remember about air? Do you remember the definition? Do you remember the properties? Do you remember the color? Like, what do you remember about air? I expect very many hands. I actually expect everyone to have their hands up, because at least you must remember the definition. You have known the definition from like P1. Yes, Nuriat says she remembers that air is a mixture of gases. Yes, Marilyn.
In the components of air, we also have water vapor. And I think I can remember the arrangement of the atmosphere.
Okay, so Nuriat remembers that air is a mixture of gases. And then under the components, Marilyn remembers that at least we have water. I think for her, that is the one that stood out the most. The others were probably boring to her. Okay, so we had water vapor. What are the other properties what are the other components of water? I'm so sorry that the work is a bit blurry. I think it's something to do with lighting. You know, it's not shining yet, so we are using this dim light. Okay, Rihanna.
Rare gases.
Rare gases. I'm going to just pick people randomly now because people are not are not what? Are not participating. Yet I know you have answers. So she says she remembers rare gases was also among the components of air. If you don't want to, if you don't want to use your microphone, you can type here in the chat room. I still get to read your answers. Okay, so Shaima says oxygen. Yes, oxygen is like the most important part of air, at least to human beings. Kalema says nitrogen. Yes, nitrogen is correct. All these things have something unique to them. Nitrogen, now nitrogen has the biggest what? Percentage composition. Then we have carbon monoxide. Carbon monoxide is used somewhere to save lives also, but not the way they use oxygen. What else? Someone has said dust. Yes, air has dust particles. Though, of course, you cannot tell their composition because they vary. You'll find that if you go in the middle of the city, the air there has a lot of dust. And then you find that when you go to maybe a place like Entebbe, there is less dust. Then also it also varies with weather. When it has just rained, like today morning, the dust is less than when it takes some days without raining. Then that also applies to water vapor. Their composition is variable. So if they ever ask you to state all the components of air that you know, and they tell you to state their respective compositions, with water vapor and dust, you just say it is variable because it really, really varies a lot. So, Marilyn, your hand is up. Yes?
Oh, no, it's okay. The answers have been...
You had forgotten. What about Mason?
Teacher, I just wanted to ask about the difference between carbon monoxide and carbon dioxide.
Okay, we are going to discuss that. We are going to discuss that right after we state the compositions. So I've already told you the one for water vapor and the one for dust. If you ever have to state that one, you just tell them it is variable, meaning that it changes. It changes according to weather, according to where you are, things like that. But then these others have very specific compositions. What's the composition of rare gases, or oxygen or nitrogen or carbon dioxide? Who can tell me? You can choose any at random and you tell me. I'm giving you the one for oxygen.
Teacher, I'm giving you the one for carbon dioxide.
What's the composition of carbon dioxide?
It's 0.03%.
0.03%. Yes, Marilyn?
I'll do the one for all the rare gases.
Okay, what's the one for all the rare gases?
For neon is 0.002%. Argon is 0.93%. Krypton is 0.0018%. Xenon is 0.0017%. Helium is 0.0005%. Yeah.
Okay, then the total?
Let me add up.
Okay. So as she adds up, can someone give me the one for oxygen or nitrogen? Okay. Skylar says oxygen is 21%. Thank you, Skylar. Let me check the chat to make sure I've not missed anything. Okay, yes. Someone had given pollutants as a component of air. I think by pollutants, you mean things like dust, fumes, those fumes from industries and all. They are also very variable. Kalema says the percentage of nitrogen is 78%. Okay, thank you guys. Then let me go back to Marilyn. Have you added up the total? Okay, Valerie, not yet, okay. Valeria has given me the total as 0.97%. Okay, now one thing you should, yes, Marilyn?
I got 0.936% as the total percent.
Okay, thank you. That's what I was actually going to comment about. These percentages, Later on, when you study more chemistry, you realize that they actually work within a range. They are not as specific as we state them now. But at this level, if they ask you, you just state them the way we've stated them. You say 78%. But then later in future, when you carry out the experiments yourselves, or when you read more into these gases, you realize that the percentages are not very exact like this. You'll find that they can be 0.93, the way Marilyn has said. And then you'll find that sometimes the percentage of oxygen is not 21, it may be 20, it may be 22. But of course, we had to decide, not we, the chemists that were there at the beginning had to decide which percentage is most reliable. So you will find that this one is very reliable. If it's to change, it will change by like 1% less or 1% more, or just decimals. Okay, now that we've discussed the components, so the components of air with their compositions, I think I'm going to answer these people's question, the difference between carbon dioxide and carbon monoxide. Okay, I'm glad you asked, because some people just ask, if you want to note, you can just note a few of these things. I'm going to just discuss through, and then if we need to repeat anything, we shall repeat it. Then I'll emphasize the new things. The reason why I'm just rushing through this is because I know you people have looked at this in P6, I think from P5, P6, P7, and you even looked at it already at school. So when we reach the parts that are a bit new, there I will slow down. But if you have any specific questions, you can always ask at any point. The way people have asked the difference between carbon dioxide and carbon monoxide. Carbon monoxide. Okay, last time during the first lockdown, the first one, when we didn't even know when we were coming back, there was a group that was with me. It had some of the people here, then some of you just joined. It had Aliyah, it had Ashley, it had, okay, I'm not saying most of the people here, I'm wondering why. It had, yes, Rihanna was there were some people. So when even Melissa, where did the other people go? I don't know, maybe they'll join us later, or maybe they're tired of over-repeating themselves. Okay, when we're discussing with those people, we discussed a lot of things. Among those things, we discussed like the what? The parts of air. No, not air, sorry. We looked at components of chemistry in a different way. There are so many ways you can classify the things in chemistry. You can classify them as mixtures or compounds. I know that one you covered, all of you. You can just stand outside and classify everything in terms of a mixture or a compound. You look at that, you're like, that is a mixture. This one is a compound. Then there is also another way you can classify things. You can use elements, molecules, or compounds. It's the same compounds that we look at when we are discussing mixtures and compounds, but we go a bit more into detail. So you can classify something as either an element, a molecule, or a compound. But now under molecules, we have atoms. I know the only new word you're hearing is element. You have heard of molecules and atoms, right? Is there anyone that is hearing those terms the first time? Okay, no, okay. But then elements is a bit new. Then you may not be very, very familiar with compounds, but as we keep on discussing, you get very familiar with them. Now, when you're looking at both carbon dioxide and carbon monoxide, you realize that they are similar at the beginning. It's both carbon and carbon. And then the difference comes in here. This one is di, but this one is mono. Then the other part is also the same. So you see that the carbon and the oxide are the same in both cases, but this one has di and this one has mono. Now, when we go back to our normal English, what does di mean?
2.
2. Di means 2. And what does mono mean? 1.
One.
Yes. So that's where the difference comes in. When you look at carbon monoxide, we are looking at 2 oxygen molecules. When you look at carbon monoxide, we're looking at 1 oxygen molecule. Why do we focus on the oxygen only? The oxides are from oxygen. Oxide is from oxygen. So dioxide means 2 oxygen molecules. Monooxide means 1 oxygen molecule. If you come across trioxide, it means 3 oxygen molecules. Then you also come across tetraoxide, tetraoxide, it means 4 oxygen molecules. So you guys have asked a question that you understand better ahead, but I didn't want to tell you people that you understand later. I wanted to tell you now. So to simplify it, the difference comes in the way they are written. Carbon dioxide is CO2, carbon monoxide is CO. So when you look at these two, this one has 2 oxygen molecules, the oxygen has 2, and this one has 1. So that is one difference, a difference between carbon dioxide and carbon monoxide. Is that okay?
Yes.
Yes.
Okay.
Yes.
Then the other simple difference between carbon monoxide and carbon dioxide is how they are formed. With carbon dioxide, you burn carbon in oxygen. It's okay, Paula. I hope you catch up. Let me not remove these. You people know what carbon is?
It's a chemical element.
Okay. Some people know. I'm not talking about the carbon in your shoes, you people. Some of you may think I'm talking about that carbon in your shoes. That is not even carbon. I don't know what it's called. Okay, maybe if you call it carbon mugen, but just carbon, that is not the carbon I'm talking about. The carbon, carbon is an element and it exists around us almost everywhere. Okay, so Kalema thinks that it's an element or substance that cannot be split into simpler substances by chemical means. Okay, then Mason says it's an element. Yes, it's an element. Then Kalema has just defined what an element is. Okay, thank you. I see some people already have an idea, but it's okay. I just want to answer these people. Then later on, we shall look at these things in detail. So carbon is found in everything that is organic. Things like food, things that are organic are things that can rot, things that have life in them. So we also have carbon in our bodies. There is carbon in plants. There is carbon in charcoal because charcoal is got from trees. There is carbon in paper. You will realize later that when you burn these things in air, these things that contain carbon, things like charcoal, things like wood, for people who use wood, whenever you burn those things, that carbon in those things, it reacts with the oxygen to form either carbon dioxide or carbon monoxide, depending on how much oxygen is there. So if the oxygen supply is a lot, you form carbon dioxide. That's why carbon dioxide, for it has 2 oxygen molecules. If the oxygen supply is very little, you form carbon monoxide. That's why carbon monoxide only has 1 oxygen molecule. That is also another difference. This one is carbon monoxide is formed when you have less oxygen. This one is formed when you have a lot of oxygen present. Then the other difference is this one is not harmful. Carbon dioxide is not harmful. That's why they tell you people when you breathe in some carbon dioxide. You people know that, right? When you breathe in, usually in primary, they ask you, what air do we breathe in? And you people say oxygen, and they mark you. But later on, you realize that you actually breathe in everything. You breathe in the oxygen, the nitrogen, and then it's the lungs that choose that now we need oxygen, now we need what? So you people actually breathe in carbon dioxide, but you don't die. Then you people even drink carbon dioxide when you're taking Coca-Cola, when you're taking Fanta, you drink it. When there is a fire and you use a fire extinguisher, of course, some people who are there may breathe in that carbon dioxide. So carbon dioxide is not poisonous at all. Carbon dioxide is not poisonous. Then now carbon monoxide. Oh, carbon monoxide is very, very poisonous. It is very, very poisonous in a way that it will kill you and you won't even know how. Like it does not warn you. It's not like you bleed or what, nothing. You will just be there and then you'll start feeling sleepy and then you will sleep forever. It's very, very poisonous. That's why they tell you people, if you're cooking from your house or if you're burning something, always make sure the room is well ventilated. When the room is well ventilated, a lot of oxygen in. So if that charcoal or whatever you're burning is getting enough oxygen, you won't form carbon monoxide. You will be forming carbon dioxide, and the carbon dioxide will go out. And then also they tell you people when there is a fire, let's say there is a fire in a dormitory, God forbid. If there is a fire in a dormitory, most of these people died before the fire even reaches them. It is because of carbon monoxide. Because of course later, the room is filled with a lot of smoke, no more oxygen is coming in, yet things are burning. So whatever carbon is in that room will start burning to form carbon monoxide. And then the people will breathe in the carbon monoxide and die. By the time the fire reaches them, they are already dead. Okay, Joria says carbon monoxide is a gas that is formed by a combustion of fuels. Anyway, I hope I have answered your question. The people that had asked the difference between it was
yes, teacher. Thank
okay,
you.
then later on we shall revisit it. Later on when we are looking at things like elements, atoms, molecules. Then Henry has asked, let me see his question. Henry asked, what's the difference between an atom and an ion? Now that we shall also look at that when we look at that topic. But one thing you should know is that ions are got from atoms. Okay, Marilyn has answered. Let me see. Marilyn says, atoms are the smallest indivisible parts of an element that can take part in a chemical reaction, while an ion is a particle with an electrical charge. That is actually correct. Thank you, Marilyn. It seems people want to study those things. You don't want to study air. I'm seeing people are taking me. I think they're like, hey, teacher is teaching easy things, but we want to look at new things like molecules, ions, what. But let's just revise through for the sake of people who had not yet finished, and we shall reach those things. We shall reach them, I tell you. Because these things, since we already know them, we shall just be revising and we shall reach them. But anyway, the simple way I can put it for Henry, ions are got from atoms. The difference between atoms and ions is that ions have charges. So for example, if the atom of oxygen is O, if you see the atom of oxygen, its ion will be O2+, where the charge is this 2+. The charge can be either positive or negative. So we call this a charge. And later when we learn those things, we shall find out why do some ions have plus and others have minus. So we shall look at all those things. Is that okay, Henry?
Yes.
Okay. But you've got an idea, eh? With atoms, you just have an atom. With ions, you just have a charged atom. Actually, you can define an ion as a charged atom. If they ask you what is an ion, you can say an ion is a positively or negatively charged atom. Okay, where were we? We had discussed the components, the what. Okay, let's now discuss the properties. What properties are there? So someone is asking the difference between ozone and oxygen.
Can I try?
Okay, yes, Marilyn.
The ozone layer is a layer which protects us from direct sunlight, while oxygen is the air we breathe in that helps us take part in respiration.
Okay, yes, that is true. The ozone layer is that layer that protects us from direct sun rays. You know that the sun rays don't reach us directly. Do you guys know that?
Yes.
Okay, if
Yes.
you didn't know, now you know. There is something that protects us, though, of course, these days that something is getting spoiled. We have spoiled it. That means one day it won't be there and we shall be getting direct sun rays. Who knows? Maybe that is the hell. Maybe that is hell. Maybe that's what hell will be like. Yes, Henry?
The ozone layer, the ozone layer is a layer that protects people from direct sun rays, while oxygen is a part of air that we breathe in.
Okay, thank you for your answer. But then that is correct, but I think the reason why she asked is because there is actually a relationship between the ozone layer and the oxygen. Okay, Mason is saying ozone can be destroyed by carbon dioxide. I told you guys, carbon dioxide is not a dangerous gas. Carbon monoxide is actually a dangerous gas. Then later, actually, I think still under air, we're going to look at all those deadly gases. There are gases that are deadly. Those are the ones that destroy the air. Okay, carbon monoxide contributes, but not a very big percentage. So let me tell you people the other difference between the ozone layer and oxygen before I ask what Aliyah wants to say. Oxygen is O2, the one we breathe in, the oxygen molecule, it is O2. Then the ozone is O3. So they are both from O, but the ozone is O3, the oxygen is O2. Why? When we study molecules and atoms, we shall find out why these things are like this. Why some have two, some have three, some have four, some have only one, okay? But I think she asked because there is actually a relationship between oxygen and ozone. So the ozone layer is this one, is the one that protects us from direct sun rays. Then the oxygen we breathe in is this one. The oxygen we breathe in, the oxygen that plants use to germinate for O2. Okay. So Aliyah. I like that you people are curious. You have so many questions. Ali, I have not had your question.
I forgot what I'm going to ask.
Sorry, Ali has forgotten what she wanted to ask. This is why I need sleep. Okay, Aliyah, can you please type your question? Please, can you type your question so that I get to hear it? Okay. Then I'm seeing there is a discussion in the chat room. Someone is asking what does the word carbon mean? Carbon is a name, the way you're called Joeria. Of course, some names have meaning, some don't, but carbon itself is a name that is given to an element that we find mostly in organic things. So carbon is just a name. The way you see oxygen, the way you see nitrogen, all those are elements. We shall look at other elements like sodium, potassium. So carbon is also another element like those one. How is carbon dioxide formed? Now that forming carbon dioxide, that is a topic you learn in like S3 or OS2 if your school is like. But then I also told you how you form carbon dioxide. You form it by burning carbon in a lot of air. Basically, you get carbon and you burn it in open space because like the normal environment has a lot of oxygen. So if you get wood and you burn it from somewhere there, or you burn rubbish or what, you form carbon dioxide, because whatever carbon is in the wood or what is burning in excess oxygen. So you form carbon dioxide. Then carbon monoxide is when you're burning in limited supply. For example, you're in a small room and you're burning wood. Gabriela, can you please mute? There is some, I think it's feedback or noise that is coming through. It may distract the class. Please mute, Gabriela.
Yeah.
Okay, thank you. So you find that with carbon monoxide, if you burn something in a closed room that has no windows, has nothing, after some time the oxygen in that room will reduce, but then the carbon will keep burning. So that carbon will burn in limited supply of oxygen. So when that carbon burns in limited supply of oxygen, that's when you form carbon monoxide. Okay, earlier had it answered. Can diffusion take place in atoms for plasma? Yes, diffusion takes place in atoms. That is how food, because don't people wonder, we eat meat, we eat what? We eat meat, we eat bread. But what our body actually needs is not meat or bread. It is the smallest and smallest particles of those things we eat. So after digestion has happened and everything occurs and everything has been turned into sugar, the sugar will enter the blood and it will move to all body parts, your brain, your feet, your arms. Now, when it reaches there, how does that sugar reach those muscles or those brain cells? It is through diffusion. So yes, diffusion can take place in atoms for plasma. Is ozone made of oxygen? Yes. It's made of oxygen atoms. It's made of oxygen atoms. When we learn the difference between atoms and molecules, then it will be super clear. Teacher can, okay, what are the chemicals responsible for the hole in the ozone layer? Those bad gases are the ones responsible for the chemicals in the ozone layer. And since we are looking at air, I think at the end of air, at the end of the topic, we look at the gases that are harmful, things like sulfur dioxide, nitrogen dioxide, those gases. They are the ones that damage the ozone layer. Usually they come from like industries, you know, those industrial fumes, and some very big laboratories, not these normal small laboratories from your school, but those big laboratories that produce things on like a large scale. They also release some fumes in the environment that are bad for the ozone layer. Is oxygen an atom or an element? It is both. There is the oxygen atom, there is the oxygen molecule. But then both atoms and molecules are under elements. We shall learn these things. Jory has said, people, let's first stop the curiosity and learn. You will learn all these things, you people. We are really going too ahead, yes. Okay, I think I've finished. Okay. So I'm seeing hands up. I hope you people are giving me the properties of air. Yes, Marilyn, what's the first property of air?
I had two things to say, but I will first start with the property of air. Air can be compressed. And someone was asking what freon is. Freon is the gas which destroys the ozone layer because the hairsprays which people spray is destroying it. And also, the difference between a molecule and an atom is that an atom is the smallest indivisible particle of an element which can take part in chemical reaction, while a molecule is the smallest indivisible particle of an element which can exist in free state. That's what I wanted to say.
Okay, thank you, Marilyn. Ryan, are you giving me your answer? The people that are sending answers in the chat, I'm seeing your answers.
Air exerts pressure.
Air exerts pressure. Yes, Maysoon.
Air has weight.
Air has weight. Thank you. Yes, Melissa. Yes, Melissa.
It's an answer, but they have taken it.
They have taken your answer. Okay, it's fine. Nuriat.
Can be compressed.
Air can be compressed. Thank you. Henry, do you have an answer?
Up with the question again.
We are looking at properties of air.
The properties of air. Air
Mm,
has weight.
air has weight. Okay. Then I remember
Air
there is
occupies space.
it occupies space. There is that. Is Farid in class?
Farid is not in class right now. He's again in another lesson.
Okay. Okay. Now all the properties you've given me are correct. Air has weight, air occupies space, air has density, air exerts pressure, air is affected by temperature. Okay, actually this air has volume. These answers are the ones we used to give in primary, but I had forgotten about them. But now that you mentioned them, they actually make a lot of sense. One thing you will realize about things like chemistry or biology or math is that the more you learn, the more you understand the work behind. The more you learn, when you reach S2, you understand S1 work more. When you reach S3, you understand S1 and S2 work more. So when you give me these properties, they actually make sense, but when you reach S1, we state them in a different way. When we look at properties of air, Rihanna, you have something to say?
No, teacher.
Okay. So when we look at the properties of air, we have physical and chemical. Everything you look at in chemistry, you'll be specifying these properties in terms of physical or chemical. Even with water, we shall do physical chemistry. Sorry, chemical. Then even with all those things you look at oxygen, you look at carbon and its compounds. Everything you look at, you'll be studying its physical and chemical properties. So the properties you've stated are mostly physical. Though usually with physical, we start with the obvious. We start with things we see with our eyes, things we can taste with our tongue. If you can touch, you touch. But then with air, we know that it is colorless, it is odorless, and it is tasteless. So that's the one we start with. We say it is colorless, tasteless. Over some of you have tasted air, and it is odorless. Odorless means it has no smell. Air doesn't have any smell. If your air has smell, it has been polluted. Okay? Then there you come to things like density. Air has a density. It has what? It occupies volume. Then that's when you start things like it exerts pressure. All those are under physical. I think someone mentioned it can be affected by heat. Let me just write heat. Oh, which one have I left out? But all the ones you've stated are under physical. Yeah, has weight, under physical. The reason why they're under physical is that you can test all these things using physical methods. You can just weigh, you can just measure the density, the volume. You can check how much pressure air can exert.
What
Yeah,
about
it liquefies when it is compressed. Yes, air liquefies when it is compressed. That is how we form liquid air. Then now the chemical ones differ according to which component of air we are looking at. You'll find that the chemical properties of oxygen are different from the chemical properties of carbon dioxide. So with chemical, for each component we shall be looking at its chemical properties. You're going to look at all these components. You look at oxygen, you look at nitrogen in detail, you look at carbon dioxide, you look at, okay, except rare gases. You want to look at rare gases in detail. You look at them in A level, if you do chemistry in A level. So it's okay for us to focus on the physical properties of air for now. What else do you look at under air? if I've kind of stopped reading the chat because it's a lot. It's a lot in there. So if you have something burning, you put up your hand and I'll choose you. Yes, Marilyn. Oh, this is chemistry.
We looked at the arrangement of how can I say it? Like the arrangement, like how the atmosphere is arranged. Yeah, the arrangement of the atmosphere.
Okay. But now we have like 5 minutes to the end of the lesson. Yeah? When I look at, I'm looking at this book, this one. When I look at it, in air, they discussed they defined it, then they discussed the composition, then they showed how to check percentage of oxygen in air, then separating components of air, then the uses of the components, then they looked at the pollutants, the ones that destroy the ozone layer, and then that was it. So what I'll do, I'll add in some of the things you need. I'll compare with the other book. There is a book that those people sent, the NCDC people, they added some things. So I'll add those things for you. But for now, let's discuss only the easy things since the lesson is almost done. Regina, your hand is up.
So I was saying that, can you please give me an example of a chemical property of air?
An example of a chemical property. Okay, let me give an example of a chemical property of oxygen. Now, when you look at oxygen, oxygen reacts with other elements to form oxides. If you're to look at like maybe the chemical of oxygen, it reacts. Okay, specifically when we are stating it, we say it reacts with. We say with metals to form metal oxide. We call that one a chemical property because you would have to find out chemically what metal you're burning. Then oxides are also compounds. The reason why you call them chemical properties is because of like how they are carried out. You'll find that now in that case, you may need heat or you may need a particular pressure. So we don't use physical methods to form these things. With chemical properties, most times you're forming compounds or you're separating compounds. With physical methods, you're just looking at the physical properties, things you can see, things you can touch. Is that okay, Regina?
Yes, thank you.
Okay. There were other hands up. I think there are more questions. Yes, Marilyn?
Teacher, when carbon and oxygen are chemically combined, isn't that process called burning?
Pardon?
When carbon and oxygen are chemically combined and they form oxygen, isn't that process called burning, like the process of them chemically combining?
Oh. You can't say that carbon dioxide combines with oxygen. You can't.
Chemically
Because
combined.
carbon dioxide is a compound, oxygen is a molecule. And the carbon dioxide that you have already has oxygen in it. So if you burnt them together, they wouldn't really react anything. But if you burn carbon with oxygen, then you form carbon dioxide. Yes, you call it burning or combustion. You can call it burning or combustion. We shall look at these things. But that one is not, it's not there. You can't say that you're heating carbon dioxide and oxygen. No, not really. Hey, you people, those were your questions. I saw many hands up and now I'm not seeing any hands. You ask all your questions. We have 1 minute. Yes, are they fumes too? What are you asking about? What do you mean? So if air is odorless, how about fumes? Aren't they fumes too? Are you talking about perfumes, or are you talking about like these funny fumes from industrial things? Those ones, we don't call them air. We actually call them pollutants. The same way you can have water, but then water can have soap, it can have sand, it can have anything. So you can call sand a pollutant, you can call the soap a pollutant, but the water as itself is supposed to be tasteless and also colorless. I hope I've answered your question. Yes, Zoe.
Teacher, why is carbogen added to oxygen when a person is on oxygen?
Pardon?
Why is carbogen added to oxygen when a person is on oxygen?
Who told you that? Anyway, if they add it, I didn't know they add it. I don't think they add it. But if there is anything they add into that air, it's because they are trying. Remember, when a person is on oxygen, they can't eat, they can't really do anything, but your body needs something. It doesn't need just oxygen. So they usually feed that person also through something else, but not through the oxygen. They don't put it in oxygen. If they feed you anything, they use other tubes, or they put you on drip and just feed you sugar. Like they put the sugars in the water and they feed you. That one is not there, Kalema. Carbogen, it's not there. I've written the page for you. It's page 75, Crystal. Carbon dioxide is oxygen and carbon chemically combined. Yes. Okay. Yes, Mason.
Teacher, you said air was odorless, but then there is a certain gas called hydrogen sulfide. If it's put in a room, the room like smells bad. So I'm like, how come you're saying air is odorless yet you can smell the hydrogen sulfide? Sorry.
Okay, thank you for your question, Mason. When we looked at air, we looked at the components. Now, when I'm studying the physical components of air, I'm looking at those components only. When you go deeper to things like hydrogen sulfide has a really bad smell. It smells like rotten eggs. Then there are other gases like ammonia. Ammonia is also a gas. It smells like urine. Then there are other nice gases that smell nice. Those are not, we don't call those ones components of air. Those are compounds. Why? Because to form hydrogen and sulfide, you combine hydrogen and sulfur. Sulfur is a non-metal, even it's a solid. Then hydrogen is a gas. Then you form that gas called hydrogen sulfide. Now that hydrogen sulfide is no longer air. It is a compound. And remember, air is a mixture. And remember, mixtures and compounds are different. So when we talk about air, we are talking about oxygen, carbon dioxide, nitrogen, rare gases, water vapor. We are not talking about those other gases you will form later of ammonia. Mason, is that okay?
Yes, teacher, I get it now. Thank you.
Okay, I hope Joelia also got it. She said she also not understood. Sorry, the page is 75. You guys, okay. When you studied mixtures and compounds, you found out that air is a mixture. It's a mixture of gases. And you look at those gases that form air. So whenever someone says air, those are the gases we are talking about. We are not talking about every gas that exists. Actually, if you look at the components of air, we don't even state hydrogen among the components of air. Yet hydrogen is a gas. So when we look at air, we look at those specific components we stated: oxygen, carbon dioxide, nitrogen, rare gases, water vapor, and the rest. So please don't think about those other gases that have smell. Some gases even have color, like nitrogen dioxide. It's a gas, it is brown. It has color. So we don't look, those are compounds, they are no longer air, they are compounds because you combine something with something else to form those gases. Okay, so I think I can end the lesson here since all your
Excuse me,
questions
teacher.
are done. Yes, yes, please.
Wait. I have a question.
Yes.
I was asking for your WhatsApp number.
Okay, I think I wrote it on the board yesterday. I'm going to write it again. Is there any other question?
Excuse me, how about you just make a WhatsApp group?
Yeah, let's make a WhatsApp group.
You want a WhatsApp group for?
Chemistry.
Yeah.
Okay. But I will have to look for
Like
you
teacher,
people.
we need to hand in our assignments.
For such things, eh?
Yes, like an assignment and a game group, something of that sort.
Okay. I don't have everyone's number, but I'm in the other group where everyone is. So I think I can get those numbers. Then some not on WhatsApp. We shall find a way to be contacting you people. Okay. So since questions are done, I think I can end here, right?
Yes, teacher, you can.
Okay.
Thank you very much for teaching.
Thank you,
Okay,
teacher.
next time we shall look at properties of each of the components. Then we shall look at their uses. We shall look at how to check percentage, things like that.
Okay, teacher.
Then hopefully we also, now that video, the reason why we've not finished the video is because the video is about water. And we are looking at what?
Air.
At air. So I'll get you guys a video about air next time. Okay, nice time, nice weekend.
Okay, bye.
Thank you.
Bye.
Bye.